Hello, everyone. Welcome to our Oracle AI database series that will be taking place every first Monday of the month at 10 a.m. Pacific Standard Time, unless that Monday falls on a public holiday. Today's session will focus on enabling microservices with Oracle AI Database. Microservices breaks large applications into independent, loosely coupled services, and with its growing adoption, Oracle AI Database offers features that simplify development. Now, I would like to introduce Mark Nelson and Paul Parkinson as our main presenters today. Over to you, Mark and Paul.
Thanks, Ernesto. Hi, everybody. This is Mark Nelson. Paul Parkinson is with me, and we also have Andrew Swanson on to help us. So today we are going to be talking about microservices. We're going to cover a number of different topics to give you a good feeling for this very broad area. You can jump to the next slide, please, and possibly the one after that. Um, Microservices architecture continues to be the dominant style for building new applications today. It's been very popular for many years now, and we most analysts are predicting that it will continue to be popular for at least another 10 years. The style breaks down large applications into small independent parts that are loosely coupled, excuse me, and each part owns its own business domain and they communicate with each other through simple, well-defined interfaces. As I mentioned, this has been widely adopted and continues to grow. There's a lot of important topics in this area. Just to let you know, we have more details in the slides than what we're going to actually cover. So you'll have the opportunity to, if you want to learn more about any topic, to take a look at the slides after the um, presentation and learn more. Next, please. So we've been adding features in all recent versions of Oracle, really since 12c, for microservices to make it easier to build microservices with Oracle. Some examples are the pluggable database support that we introduced in 12c, which allows you to isolate different workloads and have portable database containers that you can move to different servers. Extensive integration with Kubernetes for containerized database support, transactional event queues, which provide high performance, low latency event capabilities within the database with transactional semantics, excuse me, um, which is really very helpful for implementing the transactional outbox pattern and other common patterns in microservices. We have caching support that we added in 23 AI and is also in 26 AI that supports high performance read-only access to data and which is great for moving your data really close to your applications. We have a whole heap of JSON support, which we'll dive into later, and integration with key frameworks like Spring Boot, Helidon, and others as well. And importantly, you do not have to be on the latest release of Oracle to take advantage of these capabilities. We've been adding these in all of the recent releases of the database. Next, please. So again, as I mentioned, there's a heap of features in the database that we've added recently, and many of those are specifically there to support microservices. Of course, there's a bunch of other features, other great features as well for things like security and distributed databases and sharding and graph support and all kinds of other you know amazing features. Next, please. So patterns is a very important topic in the microservices world. It was first popularized by Chris Richardson, who owns the microservices.io website. He published a book called Microservices Patterns. And there are many of these patterns. Some of the most important and commonly implemented ones are the ones we have on the screen here, and we're going to go through many of these today. Next, please. We also have a whole bunch of great sample applications that demonstrate how to build microservices applications with Oracle. We have one called GrabDish, which is a polyglot example. It shows you how to write microservices in all the popular languages like Python and JavaScript, Node, Java, .NET, and so on. They can be deployed into Kubernetes. They have observability. They implement many of the patterns that we are going to talk about. And the sample is fully open source and available in source code format and also as a live lab, which is an on-demand workshop that you can do, um, in your own time to go through and learn about how to build the applications from scratch. Next, please. We also have a brand new one. Actually, jump to the next one. Thanks. A brand new sample in the financial uh, domain in the FinOps environment, which again demonstrates a lot of the common features and patterns that we talked about. And it shows, interesting financial use cases like moving money around, transfers, fraud detection, money laundering detection using graph technology, asset management, um, looking for signals in event streams, for example, for buying and selling stocks, and a lot of other great business use cases as well. And it demonstrates many of the technologies that we mentioned, so Kubernetes, observability, um, our Oracle REST data services product that makes it super easy to expose anything in the database as a REST API that can be consumed by a microservice. Our transaction manager, our lock-free reservations technology that Paul will tell you about later on, our machine learning, spatial, sharding, caching, event streams, and so on. So really lots of great features are demonstrated in this sample. Next, please. We have one other sample that's available, which is called CloudBank AI. Again, this demonstrates a lot of the same patterns. This is focused on Spring Boot and Helidon. So it demonstrates how you can build, a group of microservices that cooperate with each other. It again shows many of the common patterns. It shows synchronous and asynchronous communications. It shows accessing data in the database. It shows service discovery, um, passing security context from service to service, observability, excuse me, and has some AI chatbot content. And it also demonstrates some development time testing with using Oracle in containers. So again, we have a number of these samples that are all available for you to check out. Next, please. I'll skip over this one. Thanks. So let's jump into database per service, which is one of the most common patterns, which basically says that each service should own its own data, that the data is a private implementation detail, and it should only be accessible to other services through its public API. So this is commonly interpreted and implemented by people as literally giving each service its own database. And often people will use different databases for each service, which leads to a bunch of problems like, it's more difficult to manage upgrades, backups, security vulnerabilities, that sort of thing when you have multiple different databases. It's difficult or impossible to effectively share compute and storage resources between different databases. You do end up with a lot of difficulty propagating data, converting different formats. You get duplication of data, and it's a lot more complex to ensure data consistency and security and management policy enforcement and so on. And it gets even worse when you think about not just your operational data stores, but also your analytics. And this kind of approach can, we've seen this lead to a loss of faith in the reliability of the data, which is really something we want to avoid. Next, please. Excuse me for coughing. So, we think that our multi-tenant architecture offers a better way to implement this pattern. It makes it really easy to, give each microservice its own logically separate data container, which we call pluggable database. These can all be run in one big sort of Oracle server, which means that you get the ability to share resources but it provides isolation and security and scalability as well. And there's a really strong affinity between microservices, which are very often deployed in containers in an environment like Kubernetes and using database containers. So you can imagine each application container has a database container that it works with. And this approach really helps to avoid or minimize the impact of many of those issues that we just discussed. Next, please. Um, and there's a picture of what I just talked about. So next, please. And Oracle, I'm sure you know, is not just a boring old relational database. We can run it with any kind of data, JSON data, column data, graph, spatial, events, JSON, vectors. We support all common data types, any kind of workload, online transaction processing workloads, as well as analytics workloads, data lakes, all that sort of stuff. And, really we offer great productivity for developers and data scientists and DBAs, all in the one, database. Next, please. We also have got extensive support, extensive language support. So across all of the commonly used languages, Java, JDBC, .NET, Python, JavaScript, Node, Rust, Go, Erlang, R, PHP, you name it, we have got drivers that support developing with Oracle in your language of choice. Next, please. I mentioned earlier Oracle REST data services. This is a great feature of the database. It is included, sorry, excuse me, included also with our autonomous database, which makes it super easy to expose anything in the database as a REST service. Could be a table, it could be a stored procedure, um, and many other kinds of things as well. So this makes it just really easy to expose data and functionality in the database as it's standard, REST interfaces that can be consumed by microservices really easily, regardless of what language or framework they're using. They all have great support for REST. Next, please. Another thing that we think is a really innovative way to approach the database per service pattern is using a feature we call JSON relational duality views, which was actually introduced in 23 AI and continues to be available in 26 AI. It's basically allows you to have your data stored in relational tables, but accessed as JSON documents. So it sort of gives you a best of both worlds approach where your data is still, can be highly normalized. So you don't have redundant storage of data. You have ACID consistency and all those great things that relational databases provide. Um, but you can read and write the data as if it were JSON documents, which makes it much easier for developers to work with, much more natural and it avoids data duplication. It makes it really simple to do updates. It guarantees consistency, which is a big challenge with pure document databases. And it also allows you to define as many different views as you need. So you can give each microservice exactly the data that it needs without needing to make copies of the data or anything like that. So it's also, gives you the capability to say that some microservices maybe can read some part of the data, but only, can read and write some part of the data, but only read other parts. Like maybe they can, read and write orders, but they can only read line items, for example, or product details, for example. So, again, this is a way to enforce isolation for different services. Um, and also to enforce consistent security across your data model without needing to do any data duplication or copying and moving around of data. And it really provides the impression or the illusion to each microservice that they have full access to their own data. Next, please. Um, Again, this is a just a diagram here. These duality views that we're talking about can be defined using GraphQL syntax, which is a very common and natural syntax for working with JSON. So very very simple and easy to use and to create and update these views. Next, please. Okay, so I'm going to talk a little bit now about database isolation and multi-tenancy. We do have many different options available. So, I mean, you could, if you wanted to, have maximum isolation and independence. Obviously, you could go and run multiple copies of Oracle and give each microservice its own database. Um, However, as we mentioned, earlier, maybe that's not the best approach for resource sharing and those kinds of, and maintenance costs and those kinds of considerations. On the other side, on the far right, you could just have one huge big database and share it amongst a bunch of different microservices, which would give you the best data consistency and simplify your management and deployment and so on, but it doesn't necessarily give you the level of isolation that you want. Services might be able to reach out and access other services' data. Developers would be able to do things that you don't want them to do. So in the center there, you have what we think is the happy medium, where you have, one big Oracle server or one big Oracle environment, but you use these pluggable databases to give each microservice its own container. So again, best of both worlds approach. You only have one Oracle system to manage, security updates, backups, all those kinds of things. It can share the resources for compute and storage and so on across all of the different microservices, but they all have their own database with their own data. Next, please. We have been supporting also containerized deployment of the database since 19C. We provide container images that in several different flavors for both AMD and ARM architectures, and also for Mac, ARM as well as um, other ARM chipsets. We have full versions, we have slim versions and fast start versions that are great for development. For example, if you wanted to fire up a full Oracle database to run some unit tests or some integration tests during a CI pipeline, for example, you can use these containers to fire up a full environment in seconds. Um, the autonomous database is also available in a container image, as well as our sharded database and our caching technology. Um, we are planning to also support rack very soon in containers. So lots of great capabilities here to give you lots of flexibility in deployment and development. Next, please. We also have a Kubernetes operator available for Oracle, which allows you to manage Oracle databases running inside Kubernetes, as well as those running outside Kubernetes, for example, on a cloud provider like OCI or Azure or AWS or GCP, or on Oracle hardware like an Exadata, for example. The operator supports lifecycle operations like starting and stopping databases, provisioning, running backups, restores, applying patches, doing upgrades, scaling up and down, and also integration with monitoring to make logs and metrics and traces available to environments like OpenTelemetry or Grafana or Datadog or whatever you might be using. Next, please. All right, I'm going to hand over to Paul for a while so you get to listen to somebody else talk.
Thank you, Mark. Yep, I'm going to talk about messaging, transaction features, and observability. So for messaging, and these are some of my favorite topics too, coincidentally, because they're things that Oracle database has that just no other database has. So the messaging pattern and reliable event mesh. Maybe the first thing I'll mention is, microservices. In that poll, a good 50% of people said, they're new to microservices. And, it didn't just come out of nowhere. It's like an evolution of from mainframe up to SOAP to, microservices. And so a lot of the principles of software design are, apply, including messaging. And So all the advantages of messaging apply to microservices. So an event-driven architecture where you can, queue messages, set up quality of service, uh, routing, integration, all that are benefits of messaging in general. Usually, and in this case, mesh is referred to as the actual structure of the messaging. So a mesh being something that's not confined to, say, one Kubernetes cluster or something like that. It's an event mesh with these different qualities. And so, we use the long and short of it is generally in any architecture, the closer you get to data, the more eventing or messaging. Messaging and eventing you can kind of use interchangeably. Usually eventing refers to data. That's why we use that term here. But the closer you move to data, your communication is generally more event driven because of the guarantees that I just mentioned as far as event driven. And then the more you're moving out to the edge, or edge in the general sense of the term, you're providing REST or gRPC APIs. That's generally a good architecture because if you want to, have financial APIs and things like that, exposing them as REST is quite easy. So again, it just, it's nothing new to microservices, but one of the big aspects of microservices is the fact that you are decoupling, right? That's the whole, and with microservices, it doesn't even need to be Kubernetes per se, although that's the popular architecture for it. What you're really doing is a lot of decoupling and pushing down of, cross-cutting concerns. And that decoupling is, how developers were are supposed to program in the first place, but now they're forced to because, each component is its own process. And the number one question I get is how many microservices should I use? And that just depends on your architecture, right? You got the Netflix with 1,000, and then on the other end of the spectrum, you have WebLogic and Tuxedo app. You just want to add a cell phone app to, you have more than one service, you have microservices basically, and it's that decoupling. So why I give that kind of background in the messaging context is the fact that that decoupling in microservices means more network communication because it's not all in process communication. And because of that, the communication, whether it be REST or messaging, is very important. And what we have in the Oracle database is very unique. So let me get on with it. So one challenge to implementing eventing or event mesh is that they're often implemented with technologies like Kafka. And what you see on the bottom here, skipping down to the bottom left, these compare and contrast diagrams, is using Kafka with, say, Postgres and Mongo versus using Oracle database and our messaging engine, which is called Transactional Event Queue. Now, this messaging engine has been in the Oracle database for decades, like well over 20 years. This has been in the database. So it's very hardened and performant. And what's unique about the fact that it's at the messaging middleware, it being in the Oracle data in the database itself, is that you can do messaging and database operations in the same local transaction. And this is just a massive feature, especially the fact that it's been around so long. It's not some new idea. This has been in the database for a while. And so, if you come from a transactional background or know about transactions, when you're communicating with microservices, you're, and data-driven microservices in particular, you're doing two things. You're updating data, and then you're communicating that data change to other microservices, or they're asking for it, right? So if you're coming from a transactional background, that's immediately a red flag. You have two operations, right? And you're trying to get ACID guarantees, particularly atomicity, between those two operations. And it's exacerbated by microservices. Like I say, you have more services, more network communication. So this becomes very important. And a lot of what we do here, Mark and I are developer advocates. We're trying and make it easier to use the Oracle database for developers and Anders. And Anders actually has the best blogs on all this messaging, by the way. So definitely check those out. And so if a developer has to has to actually develop the transactional logic to make sure message delivery and consumption and data operations are done transactionally, that's a tremendous amount of heartache and work that is not necessary when you're using the Oracle database. So to give an example in these diagrams on the bottom left here, we have a basic order inventory flow. So order comes in, you persist it, send a message to inventory. Inventory service receives the message from the order service, checks the inventory and updates it, and sends the status back to the order service. Order service gets that message and updates the order service, right? So you see all these different operations going on. Let's look at the section that the inventory service is doing because it's actually three operations. It's receiving a message from the order service, it's doing a database operation on inventory, and then sending a message back to the order service. Now, in this world on the left, you are managing that, right? And in some cases, you just can't even manage that. But in any case where you are, it's a pain because you have to keep these checkpoints. And then, if something happened, you got to make sure you don't send the message twice. And it is a pain. And as I say, the goal for Oracle and microservices in general is that the developer is doing business logic. Everything else should be a common layer, right? The developer shouldn't have to be writing all this transactional messaging logic when it's a common concern, right? It's a common issue in microservices. So you would have to do that, in this older style or whatever you want to call it. But looking over to the right, doing the same operation in the Oracle database on the order side, any of those operations goes wrong, the receiving of the order message, updating inventory, or sending the message back, it simply does a rollback. And then that message will be re-delivered exactly once. So all these bubbles on the right-hand side, you don't have to do anything in the Oracle database. So, like I say, for the developer, the velocity you get in development by not having to worry about this is awesome. It's, you reduce technical debt and increase your development speed, your iterations. So super awesome. Hope I drove that point home. So this slide is basically saying what I just said. It's polyglot as far as languages and message types. And the extra cool thing is there really is no lock-in because just as we have the ability to support the Mongo API, you can just take your Mongo app, change the URL and point it to the Oracle database and it works. You can do the same for your Kafka app. So, if you have a Kafka app today or, you build one, you can do the blue-green against using it, against old Kafka and then using it against transactional event queue exposed via Kafka APIs. And so, it's as easy as that. So like I say, we make it so you're not locked in to an API. Of course, you can use JMS and other language and other interfaces as well, but you can use full interop via Kafka. So this is, getting into the code. This is the one line that kind of changes the world, right? That no one else has, which is this ability to get an actual database connection from the messaging connection. So this JMS session, and you can do this exact thing I'm showing here with the Kafka APIs as well. I'm just showing JMS here. You can get that database connection from the messaging engine. So all of the rest of the APIs are just standard JMS or Kafka if you're using Kafka. So starting a transactional session, that's normal. The getting the connection from the JMS session is what's special, as I mentioned. Inserting the record in the Oracle database. And again, as Mark mentioned, this is all using different data types as well within the same transaction. So you are inserting a JSON document in the database, but you're updating the inventory, which is generally in relational format. It's the same. It can be the same, literally the same data, but you're able to use these multiple APIs in the same transaction. So that's pretty huge. And then, you're publishing a message and doing the session commit. And so all those operations happen or they don't. In addition to that, some new features in the transactional event queue. As I mentioned, support for Kafka, a Kafka connector. So if you want to keep your current system in place and have a bidirectional, propagation, a bridge, in other words, that exists with 12 times better throughput than the Confluent connector, which we also support, but much faster. The Spring JMS and Spring Cloud Stream binders for transactional event queue. High performance has been a lot of work done on this in in-memory caching, multi-process queue-to-queue propagation, etc. Prometheus and Grafana support, which I'm going to get into a bit more as far as observability, but in particular for AQ, there's been more exposed. And AQ to transactional event queue migration. So AQ was the original name for this messaging engine. Then we added basically sharding and some other features, and it became transactional event queue. So there's a migration tool. It's not a huge deal, but there's a migration tool to make that even simpler. Okay. So moving on to my favorite topic, and this is actually the reason I came to Oracle, 500 years ago in the first place. These just unmatched transactional processing features in the Oracle database. And again, this may seem like the low-level, boring stuff, but this is the stuff that, as I mentioned, frees up developers to do the business logic and the AI and everything else that's cool without worrying about, all the blips in the system due to transactions and having to get the admin in, the need to get the data, the DBA in. Developers and DBAs should talk to each other, but if they don't have to, that's maybe better. So again, these are, these core low-level concepts, making it simpler for the developers so the developers, free to do other things. So there are a number of different topics involved here. But one of them that I'm going to get into is the saga pattern. So when you have more than one microservice involved in the same business transaction, involved in the same, data integrity, in previous systems, you might use something like two-phase commit or XA, which is a protocol that used distributed locks. So distributed locks are great because at the end of the transaction, all you have to do is a rollback and a commit. But they are meant for short-running transactions, very short-running transactions, and they use distributed locks, as I said. So the problem with them when you move into microservices or when you move into any architecture with extra network latency is that these locks may be held open longer than they can be. And you're not just going to get delays, you're going to get errors, in the lock held in doubt by whatever transaction. So they are possible in it is possible to use the old protocols like two-phase commit and XA in microservices and in Kubernetes, but it has to be a controlled environment with low latency and things like that, which may not always be the case. And when that's not the case, the saga pattern is the most popular pattern for keeping this transactional integrity between these microservices, right? And so, in short, the good news with sagas, they don't use distributed lock. The bad news is the developer has to actually implement the commit and rollback logic. And, we talked about the outbox pattern with messaging and data operations in the same transaction, the pain of that on the developer. The pain to do this compensation logic is, infamous. With numbers, usually like 80% of your workload is increased when you need to write this compensation logic, right? So imagine, you just wanted to go to microservices. I just told you it's not a big deal. But now you have this, data integrity issue. And so we really focus again, like on the hardest issues, and make them simpler. And so that's what we've done here, and we have a Saga engine to handle this. So, real quickly, I'll just go through the flow of a Saga before I talk about the Saga engine. But this is what happens: is you have your you begin your Saga or distributed transaction, whatever you want to call it, and then you ask the different participants, they enlist themselves in this Saga, and then when it comes time to commit or rollback, or in Saga parlance, complete or cancel. in the case of Saga, you have to actually do that rollback logic yourself. You have to keep track of all the changes in a separate journal, just the way the database would have with distributed locks, right? So it's a major pain. So coming back to the Saga engines, we actually have two, and one of the biggest differences is where they run. So we have the transaction manager for microservices, MicroTX, that does run in Kubernetes. And this is the Tuxedo guys wrote this, both, teams are highly experienced for both of these products. So the Tuxedo team wrote this. It actually supports the old XA and two-phase commit protocols, but also sagas. So you can do, the blue-green on that as well, that type of thing. And then, yeah, so it runs in microservices, supports a number of different languages. The Oracle database Saga coordinator on the right-hand side runs in the database. And so we can get optimizations by it running in the database. That's the long and short of it. The MicroTX supports REST and gRPC. The Oracle database version supports the messaging via transactional event queues. And they both support this auto-compensating feature that I'm going to talk about next. Okay. Or actually, let me talk about some other features, then I'll talk about that feature. So these are, there's a bunch of features for transactions in 26 AI. I'll go through these super quickly. So priority transactions, people have been rolling their own for this for many years now. Basically, this is just giving different transactions priorities so that you can unblock higher priority transactions in the case of locking and things like that. So you just give it a different priority, and then depending on that, like I say, the lower priority transactions will roll back first. Sessionless transactions, these are all one of a kind, amazing features. Sessionless transactions is really amazing that they pulled it off. We've been working on this for many years. So this is the ability to suspend and resume local transactions. So you were able to do this with XA transactions before, but now you can actually suspend and resume local transactions on connections. So you're doing some work, suspend it, pick it up later on, and can resume it and then commit or roll it back. And so you can multiplex and all the advantages from that. Value-based concurrency control. So these are E tags. This is actually what's used to make that JSON duality feature that Mark mentioned work. So this is comparing exactly what it says, the values of a JSON string in order to do the concurrency and not have to have locks. So it comes in, checks the value. Is it different from last time? Well, then we know we have an issue and it has to be refreshed. Okay. So that's using E tags. And then lock-free reservations, which is, this one actually was patented by Dieter Gaulick at Oracle back in the 80s. And so we've been working on this, and a lot of these patterns like sagas and escrow or lock-free reservations, they really find their place in microservices, right? The need for them is there, which is why we've released it now. So lock-free reservations, real quickly, I'm going to go through it in more detail, but real quickly, it does a few things. It eliminates hotspots on frequently updated fields and also provides the auto-compensating data types to get rid of the necessity for developers to write all that compensation logic for sagas that I was just talking about. Okay. So I think the best way to describe lock-free reservations is to do a compare and contrast, a journey of database locking. So if we first look at pessimistic locking, super fast but slow. This is one transaction at a time. So it's not serial updates, but T1 is going to get its data. It's not going to get robbed by transaction 2 or anything like that. Okay, so like I say, super safe but serial processing. Then comes and that's your select for update is pessimistic locking. Optimistic locking, we now have concurrency, but you have to have some mechanism in place. You have some key of a timestamp or content or whatever it is in place such that you can tell if updates were made. And so we get the concurrent access, but older transactions will lose. If a second transaction comes in, does an update on that same data in a commit. When T1 comes in and checks, it sees that it's been manipulated by another transaction, therefore it has to roll back. Okay, so those are the trade-offs. So now enter this lock-free reservations, or if you want to look up for the patent and the tech paper, it was originally called escrow locking. What it does is it has two mechanisms, two big features and two mechanisms that make those two big features work. So what's happening here is the activity is being done at a field level. So to enable this feature, again, it's for developers, super easy. It's just a new keyword you put on your field. The field has to be numeric. Um, but on your field, you just put the keyword reservable, and that's now you've enacted this feature. And so what that does is when there's concurrent access to this field, not the row or table, it's at the field level. That's the one unique thing. Um, there is a journal that is written, which is the second part of the mechanism. The one is the field level access. The second is the fact that there's this intermediate journal, and it is keeping track of changes that are made, and it's not flushing them to the table until commit time. And so you're able to get this concurrency, these hotspots like that, an inventory field is the classic example, gets much greater throughput. And older transactions do not lose because you've given them promises, you've given them reservations, thus the term. And so that's the benefit. You high concurrency parallel updates. And now the fact that we're using a journal internally to do this doubles as the journal that you would have to write and wouldn't do as well because you're not the database if you were a developer implementing sagas. So now all you have to do is call, the saga commit or rollback. The database will check this journal and automatically do the correct compensation for you. So you don't need to keep a journal you don't have to keep track of when recovery fails. There's just so many scenarios where things can go wrong with sagas. It's all taken care of by the Oracle database, and you're back to your original commit rollback simple logic, right? So massive problem, that's remedied by this feature that we have in the database. So I spend a lot of time on this, and I go into some detail because it's awesome, but also to show you, like the biggest pain for developers is what we've been addressing here. The next topic I'll go into just very quickly is CQRS. So this stands for Command Query Responsibility Segregation. This is, again, another old pattern, but the long and short of it is, just as the name mentions, it's separating the APIs that you use for command and query. So for SQL or JDBC or whatever you're using, you've been using maybe the same API to do inserts, updates, and selects. Well, what this pattern says is, divide the two of them up to decouple them and to optimize. So you might be doing your inserts with JDBC, SQL, whatever it is, but your queries might be coming via messaging. And so this is good for microservices as well because you're getting data as you need it. You're not drilling down, querying. Certainly, you're not querying across microservices. You're not doing mid-tier joins and things like that. You're writing to the database, and then you're listening for data that you're interested in. And that may be, different from what you wrote. And as I say, you may be using a different API. So super powerful pattern. That's the basic pattern. Now, when it gets into implementing it, you may want to do it a few different ways. Of course, you can just do exactly what I've been showing is that you do your transactional writes and then transactional event queue you're listening to for particular events, and you do your reporting based on that. And there's the Golden Gate feature as far as a data mesh to replicate that data. And then another option is what Mark mentioned as far as True Cache. I better pick up the speed. True Cache, which is an in-memory consistent and automatically refreshes SQL. This is kind of nice compared to Redis because it's straight up SQL. You take the app you had now add this and you have a caching layer. You don't have to use Redis APIs or anything like that. And you can see how this would be used for CQRS as well. So you have this caching layer. Okay, and yeah, so as I mentioned, these are some of the advantages of true cache, particularly for microservices. Again, it's taking away developer responsibility. Okay, observability. Be real quick on this, even though we have an amazing observability story. Um, the observability, in microservices, it becomes very important because you have more moving parts, is the long and short of it. And you'll use it for, distributed environments to find issues, tune performance, do planning, etc., right? So we have observabilities for the big three, logs, metrics, and tracing. And, some people mention events in that as a fourth as well. So we support that as well. And just the long and short of it, any kind of observability or tool you're using is going to follow the OpenTelemetry cloud native standard. And we support all those products, right? And so we have exporters, as I mentioned, for all three types, metrics, logs, and tracing. And it's an open source exporter. And what's nice about it is okay, it doesn't show it here, anything you can write SQL for, like that second bullet says. So you can be super precise. So your logs or metrics, whatever, you can say, I want this field from my alert logs. I want this field from my Kubernetes, my alert logs in the database, these logs from my Kubernetes cluster, and be very precise about it. And as far as the Oracle database, you can use any SQL to really, hone in on it. And then you can do observability across these using any of these tools like Grafana. So from right to left, you have a metric that seems off. Double click it, you see the logs of both the mid tier and the database tier, in sequence. And you can drill down that into tracing. So the last thing I'm really going to mention about observability is that we have a trace exporter in the database. So this is very unique. Like I say, no other database has this, where you can actually trace into the database. Usually any other database, you see the tracing and there's a big node when it comes to the database. Then you got to grab your IDs, then go over to the database tool and correlate them. We have the ability to propagate that ID into the database and then export the traces. So you see one long trace, and that's what you see here is a trace all the way from like the cell phone into Kubernetes, into the database file system. It's just end-to-end observability. So sorry about that, Mark. I went a little bit over, but I'll pass it back to you.
One really interesting thing that Paul said is that we really focus on the hardest problems and making them easy. And you can go to the next one, please. And one of the hardest things in microservices is dealing with all of the cross-cutting concerns. So things like security, configuration, observability that Paul was just talking about, service discovery, deployment, standardizing your build and test pipelines and all that kind of stuff. And there's a pattern that's called the microservices chassis pattern, which is where you basically take all of those things and you create a versioned platform so that they're all sort of standardized across all of your services. So this really helps, when new microservices teams are getting onboarded, they don't all need to go through that same journey of learning how to deal with all these different cross-cutting concerns, and you have some standardization, which helps with, enforcing security and management and vulnerabilities and all that kind of stuff. And the versioning part is important because it means that services can choose when they want to update to the newer versions and take advantage of new features and so on. There's a very closely related pattern in the mobile world called backend as a service, which is where you basically provide developers with a simple set of APIs to let them access all of the platform level services that they might need to build an application. These are very, very similar patterns. Next, please. So we have a product called Oracle Backend for microservices and AI. This is free to use and it is fully supported if you also have Oracle database. It can be deployed on premises or on any of the major clouds. And it implements the microservices pattern for building microservices with Spring Boot and Helidon and Oracle database. Also includes an AI capability, which I'll drill into a little bit too. Next one, please. Um, so um, yeah, the Kubernetes operator that we talked about, and the exporter, and pre-built dashboards for Grafana, and all kinds of capabilities like that. It also includes the ability to run self-hosted LLMs, which is really important to for three reasons. One, to keep your data really close to your LLM. Secondly, to keep your data private so that it never leaves your environment and goes out to a third party who could access that information or use it for training newer models and so on. And also, thirdly, for having predictable and understandable costs. Because if you're running on your own GPUs, you know exactly how much it's going to cost you to operate those up front. And you don't have to worry about, the exploiting API call problem. Next one, please. Um, so this microservices sandbox that we have allows you to easily try out lots of different language models, embedding models, to try different hyperparameter settings, different prompts, to use different strategies for chunking up your documents and setting up your corpus of information, and so on. So it allows you to, do rapid experimentation with lots of different AI technologies, especially for retrieval augmented generation and agentic techniques. Next, please. This also has the ability to generate source code for you, microservices source code. So, after you have done your experimentation and you've optimized for whatever you're interested in, the best accuracy, lowest cost, best performance, whatever it might be, and you've worked out, which LLM to use, which embedding model, how to do your chunking, what hyperparameter settings, and all that sort of stuff, you can essentially click on a button and it will spit out microservices source code in either Java, Spring Boot, or Lang4j, LangChain Python code for you. That's set up to use your models and works out of the box with the Oracle database vector store. Really, easy and great way to try lots of different options and work out what's the best way to implement a AI application, and create a microservice. And one more slide. We have also a la carte option. So the Spring Cloud Oracle project, for example, has a whole bunch of these different components that go into this chassis, that you can pick and choose the ones that you're interested in. So, if you're just interested in using, for example, the generative AI service and streaming and JSON, then you can just pick those three. You don't have to take the whole kit and caboodle, so to speak. And actually, I have one more slide. Just a couple of final points that we want to leave you with. We've been doing a heap of work here to really provide extensive support for microservices, and we think really a lot more than any other database vendor has done to make it really easy to implement proven microservices patterns, using the Oracle database. And again, a reminder, you don't need to be on the latest 26 AI release to take advantage of these features and capabilities. A lot of these have been available in 19, 21, 12, earlier releases. So don't feel like you have to be, on the absolute latest version to get benefit from this. And I will hand it back now to Ernesto. Thanks.
If you do want to learn more, here you'll find a few links that will help you walk through Oracle Cloud, get some good hands-on experience. There's some detailed documentation, our Live Labs website, and Oracle Learning Library videos on YouTube. And once again, you'll have access to this deck and link on our Day One and Beyond page in Oracle Cloud Customer Connect. And if you enjoyed this session and you would like us to conduct personalized training sessions for your organization, as in one-on-one sessions, just Oracle and your organization, do email us at our personal training email located here at the bottom of the slide, and we'll reach out to you. If you want us to conduct hands-on labs, we have our newly designed Quick Shot Live Lab program for a more expedited hands-on learning experience for specific cloud topics. Under our Code Innovate program, we co-develop well, it's called developer experience now. I'm sorry. We basically co-develop a solution based on on your own use case. But please remember that personal training is an investment we make in our customers to help them grow and develop their OCI skills at no extra cost to them. So if you are interested in any of these services, please reach out to us via this email. And here is our day one and beyond session and upcoming sessions for the month of December. Um, you still have an opportunity to attend a couple more sessions this month within our hands-on series, our cloud security series, our core series, and also our Did You Know What's New in OCI series. Now, our next database session will be next year on January 14th. In this session, you will learn how to supercharge Oracle AI database with model context protocol. Thank you very much. I hope you learned something new. Thanks for joining today's session. We hope to see you at the next one. Thank you again, Mark and Paul, for your time today. Great session. Hope you all have a great day and you're free to drop.